Hello, everyone, and welcome to another Jakarta Tech Talk. Joining us today, we have Tyler Van Gorder to discuss automated refactoring for Java-based applications. Tyler is a software engineer at Modern with a strong interest in learning new technologies, defining pragmatic approaches to software architecture, and sharing with others. If you have any questions for Tyler as we move through today's presentation, feel free to ask it in the chat or using the Ask a Questions tab at the bottom. So without any further delay, Tyler, over to you.
All right, thank you. Thanks everybody for coming. I know people are probably fatigued from online meetings this last year and a half. So I really appreciate you taking the time to come to this presentation. Today we're going to be talking about large-scale automated refactoring, and more specifically, we've got a project called Open Rewrite. It's actually an ecosystem project. It's an open source semantic type-aware search and transformation framework. It's a lot of words. But this framework basically, it allows you to automate things that are typically tedious. So sorry. So Open Rewrite started at Netflix in 2016, and it was originally, the intent was, Netflix had a logging framework. It was very similar to SLF4J, and they wanted to move to SLF4J, and they needed to figure out a way to kind of migrate all of their microservices to this common framework. So you can imagine, with Netflix culture of freedom and responsibility, there was a wide range of styles and different frameworks in place. So it actually is kind of tricky. Even though the framework logging, it's not that exciting, but there were slight differences between the API. So for instance, the arguments for passing parameters were in different orders and that sort of thing. So it was a little bit tricky and not easy to do with something like regular expressions. Additionally, because Netflix had different styles, it was really difficult to build something that would automate this and kind of maintain the same styles. So Open Rewrite was a framework to kind of built to kind of tackle these problems. So a couple of things that it can do. Obviously, it can take code that typically you wouldn't be able to do with something like regular expression and transform it. It can also be used to patch security vulnerabilities. So think if the CVE comes in, there are a lot of tools out there that will detect that you have a security issue. Open Rewrite can find and actually auto remediate those things with using what they call recipes. And then finally, a couple other things it can do. Finding and fixing issues that are reported by stack analysis tools. So I think everybody has Sonar, or something similar in their CI pipeline. And basically you get these reports and you get these really nasty, hey, you've got 60 days of tech debt because of these issues. So again, Open Rewrite is a framework that can not only report these issues, but can also remediate a lot of those. And then finally, I think that if this this takes off a little bit more, we really definitely see this being used for framework migration. So think of library authors like Micronaut, Spring, Quarkus, that sort of thing. When they make a breaking change, wouldn't it be nice if you had a tool that could help your users migrate to the new versions? And again, Open Rewrite has the capability of doing that, and we're going to show a lot of demos today where we basically, we'll show this in practice. And then specifically, since we're talking with Jakarta folks, we will definitely focus on some of the Jakarta stuff, and also migrating to a new version like Java 11 and Java 17, and some of the pains that come with that, like moving from JavaX to Jakarta namespaces, adding dependencies for like JAX-B and JAX-WS to your runtime when you move to Java 11. These are the type of things that Open Rewrite is really good at. So bear with me. This is a very slide-light demo or presentation. I think I have a total of 7 slides, including the title and like the end. So there, you won't hear me drone on too much longer. So let's keep going. So for code, maintainability is destiny. I mean, 20 to 30% of a developer's time is spent on these tedious, things like, you have to keep your frameworks up to date. So, you're getting support. So you're getting the latest security, updates. And of course, each migration, can potentially take, months of effort, depending on your organization. You figure changing one project, sure, you can do that in a bit. But if you're changing it across your entire org, like for instance, moving from Java 8 to Java 11 or Java 11 to 17, these are notoriously long-running tasks and can be really hard to do and really difficult across your whole org. So, and then of course, CVE patching is constant, right? You have to address security concerns. So let's talk a little about this. So Open Rewrite is built on abstract syntax trees. Again, that's not that exciting. We're not the first person or the first organization to use ASTs. However, there are a couple of attributes about rewrites ASTs that are kind of special. The first is that we have type information. I think there are probably other ASTs that have type information, semantically aware, like, you have a structure of the code in a tree, but you can tell that this variable is an int, or this method returns a string, that sort of thing. So that's one attribute. The second one, and it doesn't sound that exciting, is that it preserves formatting, and that is really actually quite tricky. Again, getting back to the original problem at Netflix, some teams might use spaces, some might use tabs. They have different indentation styles. They have different import orders, that sort of thing. There's a lot to consider with formatting. So if you're going to do any code transformations, you need to be able to detect the formatting of the code and when you make the change, so that when the automated changes are applied, they're idiomatic with consistent with the formatting of the code around them. So that's actually really quite tricky. So we're doing a Java presentation, so clearly there's a Java AST, but that's not the only thing that Open Rewrite does. We have parsers for XML, YAML, property files. So you figure not only do you have semantic awareness of Java code, but you also have semantic awareness about these fun configuration formats. So it allows you to kind of extend the platform into making changes to properties and formatting YAML. And then of course, if you support XML, we also support Maven. So we've built a semantically aware parser on top of our XML parser. So we then have better awareness when we're looking at an XML file that happens to be a POM file. We know that these are the dependencies, and these are the plugins, dependency management, that sort of thing. And then similarly, if we have a YAML parser, that opens up a lot of doors for us to do things like building semantic awareness for Kubernetes, GitHub Actions, that sort of thing. So it's definitely expanding. We also have a parser for HCL, so HashiCorp's configuration language. So that kind of lets us kind of extend into that as well. And then soon, coming very soon, we just introduced Groovy. So it has some initial support for Groovy, and obviously built on top of that will be Gradle support. So it'll allow us to do some transformations with Gradle as well. And then finally on our roadmap is TypeScript as well. So we are planning on kind of making this polyglot and multi-language. So okay. So all this talk, let's get into kind of what this is really good at. This is an example, actually, I had to do it with an organization I worked at. We were moving to JUnit 5. I'm sure a lot of people have had this task or are maybe tasked with it now. And this is what JUnit 4 looks like when you're trying to assert that a certain exception is being thrown. You have a rule here that's an instance variable of your test class, and then basically you need to make sure you set that to expect, and the framework will then do its thing. In Java and JUnit 5, they changed this quite a bit. Obviously, the instance variable went away, And now you can see that, we would assert throws, and you say, I'm looking at this class, and there's a lambda expression. So, so instead, a little nicer, really difficult to do this transformation in an automated way with, tools that are out there today. So this is kind of what got me hooked on Open Rewrite, is it actually can do this very transformation. So I was excited as a developer to see something that did that, and it can do it at scale. So, like as I promised, it's kind of a slide light presentation. I would like to go through a lot of demos, actually. So all the things you're going to see in our SaaS, this is a SaaS that Modern has set up, but all of these recipes are open source. So again, a recipe is just a unit of transformation, either a search or a transformation recipe. They're composable, but everything you're going to see here is in open source. So I will also demonstrate how you can apply these same recipes using either a Gradle or Maven plugin. You have support for doing these same exact transformations one project at a time. This is just kind of a nicer way to kind of demonstrate how Open Rewrite, or the capabilities that Open Rewrite has. So, further ado, we're going to start with GitHub Actions. I know we're in a Java talk, but I just wanted to talk a little bit about this to kind of demonstrate that not only just Java, but we do some other things as well. So recently, obviously, the Adopt OpenJDK moved to Eclipse Timurin, and basically, the Adopt OpenJDK image will no longer be updated. So this is going to be kind of a hassle for folks that are using GitHub Actions that have tons of projects on it. So this just kind of gives you an idea of what we can do here. So first, kind of like what we're looking at, what the heck are we seeing here? This SaaS, what we've done is we've basically ingested a whole ton of open source repositories. You can see we have 37 repositories in Apache. Just to give you an idea, these are not small projects. These are pretty good sized projects. So we're going to run all these recipes across this. It's kind of like a sandbox, approach. So going back to GitHub Actions. And I'm just going to select all repositories and do a dry run here. So what this is going to do is it's going to go basically traverse over all of the projects we have ingested here, find all GitHub action files, across all those repos, and then make these changes. Not terribly exciting, but you can see here, just as an example, look, it went into the workflow and just changed it. I mean, it's a pretty simple change, but you can imagine if you have thousands of these, like there are, not thousands, but there's quite a few. And then some things that we've done here is we can basically come here and say just commit all. So this is one quick way to kind of remediate, hey, let's fix all of our GitHub actions in one shot. So just kind of I wanted to first step into kind of things that are not Java, just to give you an idea what is out there. And so, we'll notice we have GitHub Actions and Concourse and Circle CI. We're always looking for new recipes, so please chime in if there's something that we're missing. Okay, we're going to go to Java now, and we're going to use some of the search capabilities of Open Rewrite. So with this, we're going to go to search, and in this case, I'm just going to, I want to find like the surface area of like an API. So we're going to go to find methods. And this recipe uses a syntax that's, it's very similar to the point cut expressions that you may have seen, or if you've ever used AspectJ. So in here, I'm going to do com Google common collect. So let's basically want to find any project that's using anything in the collect package. I'm going to use any method with any arguments, and I'll just run this across all the repositories. Why not? Okay, and we Open Rewrite treats searches basically as kind of a specialized transformation. So we kind of take advantage of the fact that we can do diffs on this thing, and we make what we call, we add a marker to the class. So like normally if you printed out the source code, you wouldn't see anything. But if you have a special printer that knows how to print markers, then we basically reify these markers as just comments, and then they show up in the diffs. So you can see here, this is just giving us an idea of wherever, it's not immediately obvious that this is, Google Commons, right? If I go to this though, let's see. Somewhere in here, there it is, Google Commons. So just to give you a quick idea, I mean, this is not terribly different from what you might get with SimGrep, but we kind of take a different approach here. Is we don't have a query language per se. We basically have these recipes that are kind of building blocks. So going back to to Java. With search, you'll see there's a ton of other different type of searches here. So we can search for, let's try this one. We're gonna look for all uses of deprecated classes. So obviously there's gonna be a ton of these. I could run this across the whole, why not? We'll just run it across everything. Oops. Okay. So you can see here, it's saying, hey, this WebMVC configure adapter, again, I just picked the first one off here, is saying it's deprecated. So let's go make sure that's true. Well, I won't be able to go to that because I am not in the right project. Let me try to find a better one here. How about we go to this? Okay, let's go to ActiveMQ. So you can see here it's saying this reliable transport is deprecated. If you click on these little bars over here, it'll take us to, so you can see we're just on GitHub at that project. So if we click on this reliable transport and we actually go here, it is indeed deprecated. So that's pretty powerful, and honestly, once you start kind of using this stuff, you really get used to the capabilities, and it's hard for you to picture a world without having this type of search capabilities, and it's really fast. I mean, like I said, we have 65 million lines of code in here, and again, I've got this filtered right now, so I'm not showing projects where we don't have any results. So you can see there's obviously going to be a ton of deprecated, APIs in use. So, okay, that's kind of the search capabilities. Let's go a different direction now. Let's go to Maven. It's kind of a similar theme. This is we're going to do some searching in Maven, but in this case, I want to do dependency insight. What if I wanted to do something like this? I want to find all Maven projects where JUnit is in the compiled scope. And go. Obviously, you wouldn't want to have JUnit in your compile scope. That's generally a bad thing. And again, we'll just look at one of these. Again, I'm picking on the projects that happen to start with A because they're closer. But again, I'll try to pick some other ones so it doesn't feel like I'm picking on the same people all the time. So in this case, you can see that it's telling us that the JUnit dependency is actually leaking in as a transitive dependency of this other thing. So if we that this is indeed a Maven file and it's in just dependencies, there's no scope defined. So yeah, it's going to add this. So again, this is just kind of give you a taste of what semantic awareness in Maven, Java, and YAML kind of gives you. You get a little better awareness in this platform. So all right, cool. So obviously the best thing to do here would be to exclude this. So yes, why can't we use, why not use Open Rewrite to actually to automate that? So I'm going to go back to Maven. So in addition to search, we have building blocks like this one, exclude Maven dependency. So we're basically going to say, all right, JUnit, I want you to remove it from the compile scope. And this time, since we were looking at that one specific project, It was Alibaba. Let me clear everything. Jars link. Yeah. Okay. And I'm going to do a dry run here. And you can see there's 2 results again. And cool. And this time it actually added the exclusions for us. So again, this is just kind of showing off some of the, this is our first semantic transformation where we've actually, made this change here. A couple of things that are really kind of non-obvious here at first, because as a human, you just go, of course, I would indent it to this level. Is we're preserving formatting. So what this has actually done is it's checked. It's finding out whether this is using tabs or spaces. It's figuring out what the indentation level is and making sure it gets, the change is idiomatic with, consistent with the code around it. So it's not just Java, but we can do that in Maven as well. So that's pretty cool. And now let's switch gears again. And we're going to go over to security this time. So we'll do some Java security. This will be our first. Again, I'm gonna kind of build on this, to give you an idea that like I said, recipes are composable. So we're going to start with a couple of really small recipes, and we'll kind of get more and more complicated as we go. So security in Java, we're going to go to core, and you can see here we have this one here. It says use secure temp file creation. So it's basically telling us, hey, there's exploitable file permissions. When you use just the normal Java IO file, create temp file, and it's saying, hey, you should probably be using this in IO version. So we're going to go ahead and click that, and let's change the repositories we're going to apply this against. Let's just do them all. The recipes run relatively quickly, so let's try this. And as I say that, you watch, it won't go as fast as I would have hoped. Ha. Okay. Good stuff. So again, it takes a while to basically provision the work on. We have a lot of workers behind the scenes doing this work, but specifically, let's go look at what it did here. So again, go to Apache Druid, and just give you an idea. So this is our first look at what the Java transformations look like. You can see here that it's not exactly trivial here. We had to make sure that we're adding the import, and we also had to make sure, obviously, that we're using files instead, and we're going to files. So we basically are taking the arguments that were originally in here and place them in here. So again, because we have ASTs, we can kind of do this kind of very intelligent change. And again, just to kind of hammer it home again and again, it is going to detect styling, and including, you'll notice that it actually put this in the right spot. It does detect import order, and we'll make sure that it puts it in the right spot. So like if you have things organized by groups and you have static imports at the bottom, that sort of thing, it will detect that and make sure it puts it in the right spot. So you can see here, it just, a bunch of these. It's pretty interesting. So that's that. Let's move over again to code cleanup. We're going to get a little more complicated here. Going back to Java, I'll just do a search this time. Common static analysis. Okay. Again, I just want to hammer home, all of these recipes are open source. The fact that we're using the SAS to kind of do this, it's just nicer to see it's quicker to see the results. All right, so what this is actually a composite recipe, which you will recognize probably if you've ever used Sonar, you'll recognize many of these things on this list. What this is going to do is not only find them, but auto-remediate them, which is super cool. So you can see, like, adding serialized UID when, a serializable class doesn't have it, big moving big decimal rounding constant to the rounding mode enumerations, things like using the diamond operator, right? Since Java 7, you don't need to specify the type on the right side when you know the type on the left side. So this is going to run all of this stuff across basically whatever repositories we decide that we're going to run it on. So for the sake of, I guess, time, I am going to clear this, and I'm going to pick on one of our own projects. I'll use Open Rewrite. We'll just pick our Spring one. Oh, all right, we'll pick Kubernetes. It got stuck in there too. And do a dry run on it. So now this is going to run all of those remediation things on the projects. So let's go see what type of things it did here. So this is basically reversing the equals so that we don't get a null pointer exception. That's pretty much what all of these are. And again, in the SAS, we always have this here. It'll tell us which recipe made the change. So that information is always attached with these changes. So you can get the same information when we're using Maven or the Gradle plugin as well. So you can get an idea, like for instance, this one's saying, hey, this is a final class. And you're like, why did it make this change? Add the final modifier. Okay, sure. There's no public or package private constructors. Makes sense. So these are just things that we've pulled from Sonar. There are obviously many static analysis tools out there, and this is an ever-growing library of these type of things. So if there's something here that isn't covered, we would love to hear from users in terms of what we're missing. So, okay, so that's I guess the first peek into a little more complex code transformation. This one's actually kind of fun too. I'm gonna do another one just because it's kind of cool. Fix serializable. All right, it's a Sonar issue, but this one's kind of interesting. So basically, if you think about this, this is a little bit tricky to automate. If you have a class that implements serializable, all of its fields need to either be marked transient, or alternatively, you need to make sure the class that is included is serializable. That's kind of what this thing is going to do. The way it works is it basically says, hey, if the source is in the same project as where it's discovered, where a field is not transient, it'll actually go and make that other thing serializable. If it's a type that is not as part of the project, it will instead make it transient. Of course, you have options here. You can say, I don't ever want to make anything serializable. I want to always make them transient. Or alternatively, I can kind of mix this. I can say if I run this recipe and I realize I have a factory that got included, and then the factory has a bunch of things that serializable, you can imagine how this would explode and everything in the world becomes serializable. So there's ways of short circuiting this work. So I'm going to run this against, let's see, let's pick one. JFinal, sure. Okay. So we'll just see what it does here. So 7 results, okay. All right, and you can see here, it's basically telling us, based on this transformation, it's saying, hey, it marked this HTTP session as transient. Interesting. So that tells me that HTTP session is not serializable, but something about this thing is. So this thing extends hash map. And again, a lot of these things are not always obvious. But if we look at hash map, and sure enough, it implements serializable. So these type of issues can kind of leak in when you least expect them. So it's doing the right thing here. It always could take some human intervention to kind of make a decision whether or not this is indeed what they want to do, or whether or not maybe there's something else we need to do here. So just gives you an idea. It'll kind of detect these sort of things. Again, here's a map. It's saying this thing has to be transient, because of course map is it implements serializable as well. So that's kind of interesting. You can see here this window info, and it's not always obvious that these things implement serial. Like in this case, render info, implement serializable. That's pretty obvious. But again, going back to this one, it wasn't immediately obvious because it doesn't actually implement serializable. It's only because we're extending hash map that the contract kind of gets sucked in there. So again, semantic awareness is key here. Knowing the inheritance and knowing what interfaces the parent may implement really helps in these sort of situations. So cool. All right, now let's go back to something that will hit a little closer, hopefully, to this audience, since this is a Jakarta talk. We're going to try moving from JavaX to Jakarta. So we have a whole category of things that in Java we call modernize. So you're going to find things like, basically, obviously this one we're going to run here, but there's also things, recipes, and these are very much in their infancy. So I'm a little nervous to run this with this audience because, again, the Jakarta experts here, but we'll see. We'll see how this goes. So I'm going to, again, for the sake of this, I'm trying to pick different, different repositories. We're going to go to Quarkus. CXF, yeah. All right, we're just going to run it on this one, just see how this works. All right, cool, it's done. And you can see, again, because we have semantic awareness inside the Maven, the Maven structure, we can really do intelligent things. Like we can follow the dependency to the property where it's defined. So it's pretty cool that we can do this sort of thing. So you can see here, change the version, cool, to 301. So of course we're going to go from 2 to 3. We're going from Jakarta EE8 to Jakarta EE9. So we're going to have to also change the namespaces here. So that's also doing that work. So you can see here we have some building blocks for changing whole packages. So again, if not very exciting, you can see we've got this recipe that's basically cool, changing that. So it's going to be changing all the XML bind and inject, that sort of thing. So, and then let's see, what did we change here? Oh yeah, Jakarta namespace. So again, it's detecting the fully qualified name in line. So again, semantic awareness is key here. So it'll do all those transformations. And again, another important thing is it's not too crazy different, but you can tell that it's inserted in the right place. You'll notice that it didn't add the Jakarta stuff in this second group. So again, it's detecting import order and trying to do its best to put it in the right spot. So okay, so neat. That's again just in its infancy. I kind of want to show what that might look like. This is not something I actually planned on doing, but let's just go. I just kind of want to show real briefly what this stuff looks like in code. So I mentioned this already that we've got a whole framework for building this, and we're actually going to try to code one of these real quick in a bit. But I wanted to touch on again, this is just an open source project. You can get this, you get to this via GitHub. And let's see, Java X to Jakarta. So this is the YAML file. So you're going to see here that this gigantic YAML file is basically defining basically all the things we're going to do with this recipe. So just to give you an idea that some of these things are kind of imperative, and some of these things are declarative. And so just know there's behind the scenes, this stuff can be composed via YAML files. Pretty neat. Okay, so that's that one. Let's go kind of a different direction and go to Java. And again, you'll notice that we have things from Micronaut, for Quarkus, and for Spring. I'm going to run a couple of these just to give you an idea. So we're really excited about this. We hope that more framework authors do this. The Micronaut team had the presence of mind to kind of work with us to build recipes to help bring their users from Micronaut 2 to 3. So basically, if they made breaking changes, they provided recipes to help their users migrate to 3.0 and kind of like ease the burden of moving to the new version. You could imagine this kind of drives support. You're able to deprecate things quicker. Your users aren't as pissed off because they can safely move to new versions. So let's go look at what this thing does. So in this case, I've kind of cheated. I have a specific repository I want to show. I want to show this transformation. Okay. So again, Micronaut, this is actually included with, as part of their migration strategy. So if you go to their documentation, well, okay. Oh, I picked the wrong thing. I picked Quarkus when I should have picked the Micronaut project. So let me go back to that. Let me try that again. 2 to 3. It would help if I picked the right project. So in this case, hipster sample Micronaut. Let's actually pick a Micronaut project. We might get better results. I don't know. Call it a hunch. Okay, yay, we got some results. Let's see what this thing did. So again, this is a transformation that's now going across both Java and Maven. You can see it is smart enough to traverse dependencies up into the property and go, oh, I need to make that change in the properties, not in the actual dependencies. But if the version were in the dependencies, it would make the change there. And then again, this is where it really becomes handy. Like you see here, it says type requires introspection. What the heck does that mean? We try to make a description of why this change was made with each one of these. Again, we would love to work with more framework authors, and we'd honestly love to have the framework authors more or less own these recipes with our support, so we can kind of provide this type of interaction with all the frameworks or anybody that wants to do it. So, so these are all the type, introspection. Here's one that's a little more complicated. You can see it's made a change here to once per filter. What the heck does this mean? Okay, executed once per request, directly implemented instead of extending. So, okay, what does that mean? So you can see here it changed the import. It's using this HTTP server filter now. You can also see that it went from an extends to an implement that filter, and it changed this to a protected method instead of public. Okay, cool, neat. And again, this is all being done. I would challenge you to try to do that with a regular expression. You'd have a pretty tough time doing it. Okay, so that's it. So that's just an idea of kind of the type of experience you can give your users as you make breaking changes. First of all, you're not as scared. Hopefully, you're a little bit scared of making breaking changes, but not as scared as a framework author. It just makes this a little less painful. Okay, Quarkus. I'm looking at time. I'm running out of time here. Okay. We're going to pick Quarkus. And this time we're going to do a migration to 2.0. So again, same drill, but now we're going to do this on a Quarkus project. I have 2 projects selected. I don't really need this Micronaut project for a Quarkus migration. I'll do a dry run here. Okay, cool. Same story. We're doing, again, this is going to start being kind of a rinse and a repeat. So maybe I'll stop with the framework migrations, but you get the idea. You can see here, it's just changing the version to 2.3. And then of course it's going to do a bunch of, things that are required to make this work in Quarkus 3. So let's see here, change type, those aren't very exciting. Here's one where we're basically, here's a more complicated one. So this will give you a description saying, hey, place with the gRPC client, and sure enough, there it is. Okay, cool. Here's a fun one. Factory service. You can see here, this had a whole bunch of recipes changing this. So if we go in here, it'll tell us, wow, there's a lot of stuff in here. Everything that made a change is here. Again, all this information is available when you use Maven and as well. So if you look at this, this is actually doing some pretty complicated things. It's changing. That's just a method name change. Okay, that's not that exciting. But you can see here, it's taking this chain of calls in the builder or a factory and changing it to something different. So this gives you an idea of just kind of some of the power of the framework and the things that it is capable of doing. This can seem kind of magical at first when you first see it. So neat. Okay, finally, let's see. I'm going to try something a little bit different. I'm going to show you what this experience is like when you are not in the SaaS. So to this point, you've seen all this stuff in the SaaS. It's very cool. The first thing I am going to do though is I'm going to use semantic search. I'm going to get back to the the Jakarta E theme. I'm going to use semantic search, and I'll use Maven, and I will do search, and I will say I want to find any project, and again, we're going to look at all of them. We're going to look for JavaX, XML, web. So basically, we're going to look for the old JAX-WS artifact. We're going to look for the API. I want to find projects that are actually using the API. Again, this is super cool. A little better than trying to search GitHub for, I guess, doing a text-based search. This will actually tell me all the places where projects are actually using this in one of their dependencies. So yeah, cool, meta model, look at this. Apache meta model, I'm back to picking on projects that happen to start with A, sorry. You can see here it's finding that in its sub-project Salesforce, POM, XML, sure enough, there it is. So what if we wanted to migrate this to let's assume this is a Java 8 project. Let's say we wanted to move this to Java 11. What would this entail? So again, let's go look. All I've done here is I've just checked out this this meta model project. So again, this is just obviously just out there on GitHub. Not very exciting. There's the POM for Salesforce, and basically there it is. It's definitely using JAX WS. Cool. Okay. All right, I've made a couple of changes here. Let's just go look what these changes are. I wanted to kind of just highlight this a little bit. So in the POM, the only thing I've done here is I've just added the rewrite Maven plugin. Let's make this up, make this a little bigger so people can see it. So all I've done here is, obviously there's documentation for how to add this. I'm just adding an active recipe. I'm basically, this is a new one that's in development. It actually isn't out, publicly yet, so still working on it. So this is a hint for all you Jakarta folks out there. Would love to have some help with this in terms of what we are doing with this recipe. And the other thing I did is, for the sake of just making this a breaking change that from like say Java 8 to Java 11, I'm just actually referencing a JAX-B context here. Obviously that's coming in through the JAX-WS API. We also know that if you try to run this in Java 11, that's going to break because that class will no longer be there. So let's just prove that out. So Java version, you can see I'm using Java 11. If I do a clean package, let's do that. I'm in the Salesforce sub-project, so just for the sake of time, I don't want to run the whole build for a meta model. Sure enough, error. And if we roll up to this thing, you can see, sure enough, it's saying, I cannot find the JAX-B. What the heck is going on? So just like in the SAS, you can do this from command line. So we'll do Maven Rewrite Run. And again, all I'm doing is I'm activating this new recipe that's not there yet, but again, all the recipes that you're seeing can be run through Maven. So what this is going to do now, is download a whole bunch of stuff. All right, you can see it's activating the recipe. It's going to parse all the Maven, YAML, XML, anything it finds in here. It's going to basically parse it. And then you can see here, it actually says, hey, some changes have been made. 2 things made a change. So let's go look at what the changes look like. And sure enough, the Salesforce POM has been changed. Okay, what did it do? First of all, it removed the JAX-W, the JavaX, JAX-WS API in favor of the Jakarta one. Cool, that makes sense. I wanted to do that. It's using the same scope as the original. And then additionally, it's finding anywhere where there's a transitive dependency on this API and making sure that there's also a runtime component here. And again, you can see that it's just picking ComSun and using the runtime there. So if it's made those changes, then in theory, I should be able to come back to this and run this again. Hopefully this will work now. Okay. Yay, it works. So this is a recipe, like I said, in current development. We want to make this generally available. This is going to, we have recipes similar for both JAX-B and JAX-WS, where they will do the same sort of thing. They'll detect the use of the JavaX artifact and move it to, again, you'll notice that it's using the latest version of Jakarta EE8. Obviously, we're going to have other things that will then take you from Jakarta EE8 to 9, and then do all those namespace changes. So we're trying to make these building blocks so organizations can kind of pick what pace they want to make these changes. So that just gives you an idea of what the experience is like from the command line. Again, we have build plugins for Maven and Gradle. So neat. Last but not least, I'm going to actually try to code up one of these recipes to give you just a taste of how these, the framework is used. So I'm going to go over to IntelliJ and do this hopefully very quickly. For the sake of time, I'm going to do some cheating. I have this code, pasted. We're going to build a recipe that basically is going to add the missing override annotation to any method that is overriding its parent. So again, this is something where semantic awareness really comes into play. So I've mentioned already, everything that we do is called a recipe. Okay, cool. Let's see here. All right, we'll do that. And then it's plain because there's things here we haven't implemented. So implement display name. So again, all that metadata you're seeing on the site is basically defined in each recipe. So we're making an imperative recipe here. So okay. So again, for the sake of time, I'm going to just do some copy and paste here. Okay, so we're doing that. And then the other thing that the recipe provides is it's a wrapper around a visitor model. So we use the visitor pattern for basically navigating our AFTs. So we're going to override methods here, and there is a get visitor here. And this is the visitor that's actually going to do the concrete work. So what we're going to do instead is we're going to return it. Again, notice it's tree visitor, so this could be Maven, this could be Java, whatnot. So we're going to tell it, since we know we're doing a Java transformation, we're going to use this Java ISO visitor. And there'll be a lot, there's a lot of documentation out there. So, don't feel like, if you feel like you're lost here at some point, don't worry, lots of docs, and we're actually on Slack a lot too. So we can help people out when you're first using this API. So same thing in the visitor, for the visitor pattern, if you look at the methods in the visitor, you're going to find there's a visit for every basically aspect of the Java language. So we know that we're going to be looking for a method declaration. So we'll just do visit method declaration. We're going to override the method. So basically, the framework's going to call into this, and as it traverses the AST and it finds methods, this is the method it's going to call. For the sake of time, do some more cutting and pasting here. I know that in here, we're going to be looking for a specific sort of we want to see if this annotation already exists on the method declaration. We're going to use this annotation matcher to do that. We also know that if it's not there, we're going to need to be able to add this snippet of code. And you'll notice it's just a string here. This template is deceivingly complex, but what it's really doing is it allows you to take a chunk of code that's just written as a string, and we'll then convert it to it will basically insert it into an existing AST, parse it, and then create AST elements. So instead of having to manually, you could do it. You could definitely try to manually create the AST. It's complicated. Or you can use this template to do it instead. So this template kind of aids in doing that. And then finally, let's just implement the details of this method. And again, I'm just going to paste for the sake of time here. Okay. So what this is doing here is, again, the method declaration has a lot of information that we can kind of interrogate. So we're basically saying, hey, if you're static, we don't want to make this change. If you can see here, we're grabbing all the annotations that are on this particular method. And if none of them match this matcher, meaning it's not there, okay, cool, and we're going to want to do this. And then finally, we need to make sure that we check the type information to see if this is indeed overriding something in one of the superclasses or one of the interfaces. So this is where that type information gets really useful. You can do really complex things easily with this framework. And then finally, if all of those things are true, then we're going to go ahead and you can see here we're mutating. So instead of returning basically the same method, we're going to mutate it with our template. And you can see inside here, we have these coordinate system. I'll get into this a little bit. So like if I'm inside a method declaration, these are the type of places I can insert code using this template. Like I can replace the throws, the parameters, I can add an annotation. So again, there's a lot of help here in terms of how this, and then something's kind of interesting. You notice that you're kind of may wonder, like, why do we have a comparator here? Well, this is telling us that if we're going to insert this annotation on a method, where do we want to put it when there's more than one annotation? So we're basically saying, all right, we want to alphabetize by the simple name here. So that's it. That's all the code that's required. I've taken the time already to build a kind of a unit testing framework here to kind of use this. Again, this is we switched over to Kotlin, which is why I'm using IntelliJ. I'm sorry, I apologize to all the Eclipse folks out there. I do have Eclipse installed, by the way. I have both. But this makes it easier when using Kotlin. So all I'm doing here is we're creating some stubs. So you can see here, I've just created a couple of interfaces, and then this interface extends this interface, that sort of thing. And then I have a couple of parents. And then all I have here is a couple of test methods in here. So basically saying, let me just pull this over so it's a little easier to kind of look at. So in this case, we're basically saying, if given this source code here, we expect this source code afterwards. So we are expecting, what do we have in error? Okay. So you can see here, trying to test to make sure that the sorting is working correctly. We're basically saying that because test parent, and again, this method test parent is in the test parent base class, so we kind of expect it to work that way. So if I run this real quick, hopefully if I've done my job correctly, this will actually work. Yeah, it does, and again, that's not terribly exciting. If you don't trust me, let's just do this. Let's add an extra space here. And again, we're pretty sensitive to even the smallest of white spaces. So if there's an extra white space, this thing's going to fail, and it does. So if we look at the difference, sure enough, basically it's because there's an extra white space that you can see the actual doesn't have one, but here we do. So again, trying to get this formatting correct when you're making these automated transformations is really quite tricky. We spend a lot of time making sure that this stuff works. And then I have a bunch of other tests that I think I'm running out of time. So at this point, I'm just going to, I guess end it here. And one more thing, go back to my slide deck. Current slide. Okay, last piece. First of all, thanks for coming. We really do need your help. Please come look at us. We're at GitHub, Open Rewrite. We would love if you would open an issue on GitHub asking for a fix or a migration, or better yet, if you've got some Jakarta experience, which I suspect maybe some of the people in this, watching this presentation do. We would love to get some help with some of these migration ideas in terms of further developing these recipes. You can follow Modern Inc. On Twitter. That's the company I work for. Our team is kind of split between working on the open source project, so we do a lot of work in there, and then we also have that the SaaS, and then finally all that cool, I guess, UI you were saying to use is actually available as a sandbox. So if you go to app.modern.io, you can actually play around with these things. And I would encourage folks to just kind of play around and see the capabilities of the framework. It's pretty darn compelling. Okay, and that's it.
All right. So it looks like we have one question here. Yep. Is there anything we can do to improve the resolution of the screen capture?
Sorry. Is that just geared at the video capture here?
Jonathan, I'm not sure if you can add to your question if you're still here.
That's Jonathan, yeah.
Yeah. So I'm not sure that.
Bummer, yeah.
I'm not sure if he's still in here or not, but looks like he might not be. So
yeah, okay. Jonathan works. It's probably Jonathan. I know the Jonathan. So
okay.
I guess my question is, was it just fuzzy or too small?
All right. So in the meantime, I would just like to thank you again for that excellent presentation today, Tyler. And just a reminder, if anyone has any final questions in the audience, just to pop them in the Ask a Question tab now at the bottom.
Yeah.
And then this is just a reminder, we have our next Jakarta Tech Talk on November 9th with Alex Sovic as he joins us to present Jakarta gRPC services, and you can register for that using the link I'll pop in the chat. We are also looking to book more Jakarta Tech Talks throughout the rest of 2021 and into 2022. So if you're interested in presenting a Jakarta Tech Talk, feel free to fill out the form, which I will also put in the chat. And finally, if you haven't already done so, I would encourage you to register for the Jakarta One live stream in December. It's the largest Jakarta event of the year, and you will not want to miss out as we have a load of great talks coming. So I'll put all these in the chat now. And I don't see any other questions.
Okay.
So I think that's pretty much it. So we can kind of wrap up. So thanks again, Tyler.
Yeah, no problem. Thanks.
And thank you everyone who came out. I hope you all have a great day.
Yeah. Thanks.
Thanks. Bye.